Abstract Algebra, Theory and Applications by Thomas W. Judson of Stephen Austin State University at Boston. Sage Exercises for Abstract Algebra by Robert A. Beezer, University of Puget Sound. August 1st, 2018. Somebody translated it in Spanish, I think. Annual edition 2018. The website is abstract.pugetsound.edu. abstract.pugetsound.edu. Permissions granted to copy, distribute, and modify this document under terms of the GNU Free Documentation License. Acknowledgements. All right, he wants to acknowledge the following reviewers for their helpful comments and suggestions. David Anderson, University of Tennessee, Knoxville. Robert Beezer, University of Puget Sound. Myron Hood, California Polytechnic State University. Herbert Kasube, Bradley University. John Kurtzk, University of Portland. Inessa Levy, University of Louisville. Jeffrey Mason, University of California, Santa Cruz. Bruce Miracle, Mankato State University. Kimmo Rosenthal, Union College. Mark Teepley, University of Wisconsin. Sorry if I mispronounced anybody's names. I would also like to thank Steve Quigley, Marnie Pommet, Kathy Griffin, Kelly Karshik, and the rest of the staff at PWS Publishing for their guidance throughout this project. It has been a pleasure to work with them. Robert Beezer encouraged me to make Abstract Algebra, Theory and Applications available as an open source textbook, a decision that I have never regretted. With his assistance, the book has been rewritten in Pretext, P-R-E-T-E-X-T, at pretextbook.org, making it possible to quickly output print, web, PDF versions, and more from the same source. The open source version of this book has received support from the National Science Foundation, awards hashtag DUE 1020957 and hashtag DUE 1625223. Preface. This text is intended for a 1 or 2 semester undergraduate course in abstract algebra. Traditionally, these courses have covered the theoretical aspects of groups, rings, and fields. However, with the development of computing in the last several decades, applications that involve abstract algebra and discrete mathematics have become increasingly important, and many science, engineering, and computer science students are now electing to minor in mathematics. Though theory still occupies a central role in the subject of abstract algebra, and no student should go through such a course without a good notion of what a proof is, the importance of applications such as coding theory and cryptography has grown significantly. Until recently, most abstract algebra texts included few, if any, applications. However, one of the major problems in teaching an abstract algebra course is that for many students, it is their first encounter with an environment that requires them to do rigorous proofs. Such students often find it hard to see the use of learning to prove theorems and propositions. Applied examples help the instructor provide motivation. This text contains more material than can possibly be covered in a single semester. Certainly there is adequate material for a 2-semester course, and perhaps more. However, for a 1-semester course, it would be quite easy to omit selected chapters and still have a useful text. The order of presentation of topics is standard: groups, then rings, and finally fields. Emphasis can be placed either on theory or on applications. A typical 1-semester course might cover groups and rings while briefly touching on field theory, using chapters 1 through 6, 9, 10, 11, 13, the first part, 16, 17, 18, the first part, 20, and 21. Parts of these chapters could be deleted and applications substituted according to the interests of the students and the instructor. A two-semester course emphasizing theory might cover chapters 1 through 6, 9, 10, 11, 13 through 18, 20, 21, 22, the first part, and 23. On the other hand, if applications are to be emphasized, the course might cover chapters 1 through 14 and 16 through 22. In an applied course, some of the more theoretical results could be assumed or omitted. A chapter dependency chart appears below. A broken line indicates a partial dependency.